Kosayyer is here to unveil the truth of LLMs and where they may fail. With 20 years crafting, his expertise shines. From wise heroes to groundbreaking designs, intrinsic limitations of LLMs unfold. Hallucinations and data, stories unfold.
Thanks. Hello, everybody. So I'm Naim, and as stated, we're going to speak about one big limitation of large language model, which is hallucination. Before a quick presentation, so I'm a multi-time founder. I've been through many companies. I founded many startups. I've been to IC, to many accelerators. And I've been working on data for more than 25 years now, building AI models. At that time, we called them machine learning. And before that, expert systems. So I've been following all of those trends. And I've been listening with a great interest the presentation from Matt, because now in Selfr, what we're doing is that we are automating data engineering to help companies have the cleanest data pipelines, right? And something that is super natural is that our clients are asking us to build, some kind of self-service BI. So it was like the presentation of Matt. So this is something we've been asking a lot. And the dream, I'm going to give the definition of self-service BI. The dream of every company is you have your non-technical users. Think of people from marketing, from finance, from operation, or from your C-level. They're just going to ask a question in plain English or plain French, and boom, they get the answer in the form of chart, right? This is the dream. And as you've seen, first, it's not working, and it's super, super complicated. So this is what's been asked. And when the LLMs came, everybody thought it's going to be super easy, right? You're going to have the business question from your business user. You just take this. You can add some, table information from your database, thanks to a RAG system, and you just add ChatGPT, right? And you're going to get a SQL that you can compile. But it's not working because of one thing, which is hallucination. And this is why something we see a lot is that in many, many companies, you have a lot of POCs, right? You have a lot of systems that you can build in just 2 weeks. But because of hallucination, it never goes to production, right? Because just think about it. Let's say I'm just going to give you an example. But last time we had a call with a CEO of a great startup in the Silicon Valley. I can't tell you the name. And they showed us the system that they had. And so, they asked a question in English, get the answer, a figure. And I told him, okay, what about hallucination? And he said, oh, I didn't think about that. So maybe the figure is just wrong, right? So you see, it's really a hurdle here, and you can't use it. Anyway, I'm not going to really speak about self-service BI here, but more about hallucination. So first, even if I know that you all know this, it's super interesting to just restate what a large language model, because this is something I've been reading on the internet, a deep learning model that understands and generates text in a human way. Maybe the generate text in a human way is true, but the understand one is completely wrong, right? The LLM doesn't understand anything. So I think that it's really important for us, if we want to really understand the limitation, to just see the LLMs for what they are. And basically, they are just a deep learning model, okay? That's going to predict the next word given a prompt. This is the only thing that it's doing. It has been trained for this, and it has been specialized for this. To be really clear about this is a question I've asked to ChatGPT 3.5. So I need to prepare a talk about LLM hallucination for Monday, and it's already Sunday. What should I do? So this is the beginning of the answer. And you can see that what ChatGPT 3.5 or any LLM is going to do is really predict, okay, the next token of the prompt I gave it is 1, because somehow it understood that it has to provide a list. Then it's going to predict the dots, and then formalize yourself, and So a token, it can be a part of a word, but we're just going to say a word to make things easier, right? So just be reassured, I haven't been using the answer of ChatGPT 3.5. Because familiarize yourself with the topic. I think if I had to do that, I wouldn't be here. Now, something that is really important is that each step is probabilistic, right? It's not deterministic. because of this, like large capabilities of LLMs, something that is really dangerous is that you can use it for many things. So as you know, you can use it for chatbots, for generate text, for translation, which works very well, by the way, or code assistance. But in our case, what's going to interest us, it's going to be like, the text to SQL stuff, classifying, categorizing, analyzing customer feedback, anything that you want to put in a data pipeline in an automated way. And this is where, hallucination is even more dangerous. A quick definition of what are hallucinations. So actually, there's no definition of what hallucinations are, but at least you can say that you have 4 types of hallucination or mistakes. The first one is something that is just incorrect. By this, we mean that the answer has been seen by the LLM in the training data, but for some reason that we know why, the LLM cannot just restate what it has seen before, right? So like the LLM should have been working well, but it's not. Then you have the misinterpretation. And this means that when you gave it the prompt, for some reason again, and we know why exactly, the LLM hasn't been understanding exactly what you meant. Another way of saying this is that you have been giving the wrong prompt, right? It's because of you, not because of the LLM. The third thing is, it happens when you give the LLM a huge text, for example, a PDF, and you're just asking something that is inside the PDF. And again, for some reason, the LLM can't retrieve this information because it's just getting lost in the big amount of token that you provided to him. And maybe the most dangerous one is just complete fabrication, right? Like the LLM can just give you entirely false statements that has no basis, right? It never has seen something like this. It comes from nowhere. But the LLM has been just here to produce tokens, so it's gonna do that. Let me give you an example that's really funny. So this is a message I received from a very well-known psychiatric on LinkedIn. And so it's in French, but I'm gonna say it in English. So she asked ChatGPT, some information about PTSD, so post-traumatic stress disorder. And ChatGPT has just been inventing complete stuff like trends and figures and cost in France and I don't know what. And she told me, it's really weird because I've been looking for some references in the internet. I couldn't find anything. And even worse, when I'm asking ChatGPT, where did you come from with this? ChatGPT just told her, I never said that. And this is really interesting because maybe we here, we know this, but we have to be aware that most people, even like a psychiatrist, which is scientist, they didn't know exactly that. So they can be really fooled by this. And maybe you have seen this in the news. You have now many scandals, right? For example, a lawyer in the US who had just been stating cases that never existed because he just asked ChatGPT and just trusted it. So hallucination. And just for between us, I think it's better to call them confabulation. So in French, it's affabulation. Because when we say hallucination, hallucination is really, and by the way, this is what the psychiatrist told me. I didn't know that before. But the LLM doesn't have any perceptual experience, right? A hallucination is like seeing something or hearing something that doesn't exist, right? Here it's gonna be more confabulation. And now the key point is that, when an LLM is gonna give you just bullshit, it's gonna always tell it in a very convincing way because again, it has been trained for this. You can think of LLMs like bullshitter or politician. I didn't put that in this slide. So I think it's interesting to have just a sense of why LLMs are hallucinating. So you have many reasons, mathematical and maybe some philosophical, but actually the first one is enough to understand completely why it's hallucinating. It's gonna be the auto-regressive nature of LLMs. And by this, it's exactly what I showed you earlier, so I'm gonna just re-put this. At each step, so we said that each step is gonna be probabilistic, right? So at every step, the LLM is gonna choose one token between many tokens. And so what this means exactly is that at each token that is being produced by the LLM, you are taking a risk, a null risk to be wrong, right? And so this means something really, really deep here is that the longer the answer is gonna be, the bigger the probability for you to have a wrong answer is gonna be, right? So this is what I'm showing you here. So basically, if you have just a sentence with a few tokens, you're gonna have less risk to have a wrong answer. And of course, once you have, like the LM has been chosen a wrong token, it's gone, it's gonna diverge, right? So this is something super important to keep in mind. Again, if we retake the example, the reason why I ask this to ChatGPT 3.5 is that if you do that in the OpenAI platform, they still show you for each token the probability of each token, right? So here, for example, he has been chosen the farm to farmerize, but you could see that he could maybe have been choosing the start. So this sense, I think it's going to be the same. But for other use cases, like this one, here I'm asking a very simple question, so a BI question here. Before that, I gave him like all the data structure. And so I'm asking here, what are the total sales for this year by region, and only for the West region? And you can see that at the order token, it has been wrong. And because of this, the whole SQL is wrong, of course. I think he should have been choosing the end token. Now, the key point here, and I think it's super important that we all have this in mind, is that hallucination is a feature. It's a feature, it's not a bug. And it will never be removed. If we want to have something that doesn't hallucinate, we need to choose something else from LLMs, right? And maybe you won't believe me. It's okay, I agree with this, but I just give you like one conclusion from a paper, and more importantly, maybe a quote from Yann Lequin. So you know him, he's French, and he's the chief AI scientist at Meta. And he's saying that LLMs are doomed for the exact reason that I presented you just before, right? Because of the auto-regressive nature of LLMs. And he's saying that it cannot be made factual, it's not controllable, and it's not fixable. So what can we do about that? First, I want to tell you that maybe you're gonna hear a lot people saying that, you know what, we can fix this, because actually what's missing is that we just need to train on more data, bigger data, and we need to add more parameters. And so this is basically what in the field of AI we call scaling, right? Like more compute power and more data. Actually, if we do that, maybe we're gonna fix the two first kind of hallucination. I think that we won't, but anyway, some people think that it's gonna be possible. But what's true is that the two other kinds of hallucination won't be fixed. So if we hear that, hey, don't worry, ChatGPT 5.6 with more data and more I don't know what, it's gonna fix this, it will not. If we need something that's gonna be new with a major redesign of LLMs. Nevertheless, I'm gonna present you some mitigation strategies that can be really useful for some use cases, and for the other use cases, I'm gonna just present you like a few trends of what people are trying to do. So, ideally, what we'd like to do is you have this creativity nature of LLM that is really great. I'll get back to this at the end of the presentation. And we just try to move the hallucination, right? That's on the right, it's ideally what we want. I've been speaking with a lot of people. We've been trying a lot of things. I'm just gonna give you like what really works to just reduce the amount of hallucination. The first one is, yes, a better prompt. This is what people are calling prompt engineering. For this, you can, in the prompt that you're gonna give to the LLM, give a few examples of what you want. So this is what's called few shot prompts, which by the way is really magical. Like it's some kind of fine tuning in context just for your use case, right? So by doing this, you really remove a lot the percentage of hallucination. You also have the chain of thought chaining. Just to be clear that everybody is on the same wave here, just gonna provide you an example. This is a prompt, and in the prompt, you're gonna really tell the LLM exactly what to do, okay? So you won't just like ask a question and that's it, but sometimes you're gonna say, okay, first calculate this and like step 1, step 2, 30, right? You're gonna really guide the LLM. And again, it's kind of magical because it's working much, 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 much better, especially for stuff that includes reasoning, right? Now, there's two things about that, the prompt engineering. The first one is that at some point, you have to be so technical and so precise in what you're doing that you're gonna just spend less time by doing it yourself. I mean, if you're just asking like the LLM, okay, you have first to do this and this and this and that and that, maybe you're just gonna do it yourself, right? So just be aware of this. In some cases, it's not really useful. And the second thing is that it's gonna increase the cost a lot, because like the idea that we had before is that I'm gonna just ask a prompt of, I don't know, 100 tokens. By doing this, actually, maybe you can have for each question, you're gonna have prompts of 5,000 tokens. And you know that LLMs, they charge by token. So it really goes up super quickly, the cost. So first thing is really have better prompts. The second one is something that is not really inside the LLM, but it's really important, is by providing better context. And this more relies on, all the RAG systems. So it's not really, again, about the LLMs. But again, if we take the example of Selfr BI, you're going to have the question of the business user. And at some point, you need to provide him with, your data schema. But most of you, they have at least like 1,000 tables, right? You can't just provide all of this to your LLM. First, it won't accept it. It's too long. And second, again, the cost is going to be just, you can't have this. So how to find the right piece of information to provide to the LLM, it's more about the RAG and all the RAG systems. If we have a discussion, I can tell you like our findings, but it was not the goal of my talk today. And the last one that is not very well known is try to put limits on the answer. By this is that, when you're asking a question to an LLM, you're just providing it like an infinite set of possibilities in how it's going to answer you. What you can do is just say to the LLM, okay, you need to fill a JSON, for example, or you need to choose only between this and this and this. And so here you can use templates. So I'm going to give a more precise example in a few minutes. But you can give a template and say, okay, you have to fill the template to make sure that what you're going to have at least makes sense in your business context. And by doing this, I have bad news. You won't go to the green area, but at least you're going to go close to it, but you're going to be losing some kind of creativity of the LLM. So to sum up, this is like all the stages where you can really try to lower the percentage of hallucination. Now, there's the good news of this. A lot of people have been trying this. You have some papers, not a lot, about that. You can go from 40% of hallucination to less than 10% of hallucination on average. I've seen like 5%. I've seen more, but on average, by doing this, you can lower it, but you can never get to zero because of everything we said before. But this is super important because for many use cases, and here I mean the Copilot use cases, this is super useful because what I call Copilot is all the use cases where you have a human feedback, right? So it can be, for example, a data analyst that needs some help, for his SQL. What's key here is that the data analyst is going to ask the question, but he can read the SQL and he can decide if the SQL is good or not, right? It can also be super useful for the healthcare use cases. For all the use cases where we're going to ask an LLM or an AI with all the pipeline that you can imagine to give you like, a diagnostic, but just a proposition, like the doctor need to validate this, right? And here, the key metric is going to be the percentage of hallucination. If the data analyst is going to ask like some SQL and like 4 times out of 10 is going to be wrong, at some point he won't ask it, right? It's like when you're asking the ChatGPT to write your emails, it has to be good at least 7 times out of 10. So by going from 40% to less than 10%, it can make those Copilot use cases super useful in many, many use cases, and especially for onboarding. Or when it's possible to cross-check results. So I've seen these use cases, especially in the financial use cases, because in financial use cases, you can ask the LLM to provide some answer, but at the end, the figures, it's not giving you like just figures like this. You know that these figures needs to be cross-checked with all the other figures of your finance, right? So you can check at least what he is providing you if it makes sense. For all of these use cases, if you can go from 40% of hallucination to 10%, it's super useful. Another one is going to be coding. If you want something to code, but you're providing the test to know if the function that it's providing you is good or not, you can have this also. So everything where at the end, you can take the answer of the LLM and just test it, and you make sure. Of course, for this, it's going to ask you a lot of time to build some kind of a model for your use case, right? Because like the check part shouldn't be done by the LLM. You have to build this, right? Can be a compiler or whatever. And for other use cases, it's an open field now, right? So I'm going to just tell you a little bit of what we're doing at Selfr. We started this like a few months ago. We are tackling the X as code, also called the declarative approach. It's going to be all the use cases where instead of asking, so we're doing this for the text to SQL, by the way. Instead of asking an LLM to provide us the plain text SQL, what we're going to do is we're going to ask him to fill a JSON that's going to be the specification of an abstraction layer, right? So basically, instead of telling it, okay, this is my question. So we can take the example of earlier. I want, the total sales for my region, only for the region West. Instead of asking the LLM to provide me, the SQL, like select, I'm going to ask him, no, what you need to do is you're going to fill an already done abstraction layer. So it's a big JSON. And this JSON is going to allow me to compile the SQL, right? So here you can see that this JSON is really giving you like the business components of your use case. And what we're doing is that we have been re-engineering the transformer of the LLMs. And what we're doing is that we're going to do this exactly what I'm showing here. The transformer is going to fill every value of the abstraction layer in parallel, which means that we're going to do a one-shot filling of the JSON. And this means that we don't have the auto-regressive nature of LLMs. So this is one thing that we're working on and can be applied for, test to SQL, Selfr BI, but everything that can be done as code, right? Now, a limitation is that, and by the way, it's a good limitation. If we can't fill the abstraction layer, you're asking me a question, I can't fill it. It means that the LLM, the system won't answer, right? But it's good because you can't have something that is always answering you, right? It's like your best friend who's always have an answer to any question you have. He's just bullshitting most of the time. Now, two last thoughts. The first one is, before using an LLM, just consider this question. Is your problem a language problem? Like LLMs has been done for a language problem. So for translating, for summarizing, it's really good. But what we can see now today is that a lot of people are using LLM for stuff that are not a language problem. For example, Selfr BI, it's not a language problem, right? It's a data problem. And you have a lot of data components that you don't have in the LLM. And you just have this illusion that it's working because, again, the LLM can produce anything. By the way, if you ask the LLM to produce a JSON, it's going to do it, right? But it's going to do it token after token. And the second one is that when this big ChatGPT stuff came, everybody thought that we're going to be the one that is doing just creativeness, right? And we're going to ask the AI system just to do, the dirty things, the thing that you just want to automate. Maybe, I'm just saying maybe, it's going to be the other way around, right? We're going to keep on doing the dirty things, right? The thing that we can't automate with the LLMs. But for creativeness, maybe LLMs are really better. So you can ask, the LLM, hey, give me the SQL. What can I do tomorrow? It's going to give you crazy ideas. Sometimes some crazy ideas are going to get great, but you're going to keep on doing the hard work. And for now, if nobody's doing the hard work, it's not working. Thank you very much.